Well, as we begin to do chapter G, listen to that whirling sound of cicadas. They come out once every 17 years in Asheville, this particular breed. Chapter G, the product rule. So now we're going to take the derivative of a function f of x that consists of a product of two functions. And remember, our derivative is the slope, where we want the rise over the run as the limit of delta x goes to 0. So if you think of this as f of x and x, we have some delta x here, and let's say here is our rise, delta f and delta x. The function, say something like that. So delta x and delta f. So the derivative is given by our formula, the limit, as delta x goes to 0, and at times I like to use h for delta x, and here is one example. So I'm going to have here the limit as h goes to 0, and we're going to have here then f of what I would normally write x plus delta x. I'm going to write h. In other words, we're letting h be the delta x. I think in this case it'll be less cumbersome notation. And then we're going to subtract f of x, and then we're going to divide by h. So now I'm putting in for the f, we're going to have the derivative of the product uv with respect to x is going to equal the limit as h goes to 0. And now for the x plus h case, we put x plus h in for the x. So this is going to be u of x plus h times v of x plus h, and then we're going to subtract the f of x, which is just the u of x and the v of x. So I think that h makes it less cumbersome. We don't have to see the delta x in there because it's h. And then we divide by h. Now the trick here is to subtract and add something in the numerator. So what I'm going to do is subtract and add u of x plus h times v of x. I'm going to subtract and add that. So let's do that now in the numerator. So we have d uv, the product, dx is equal to, and we'll have the limit as h goes to 0. And we'll write the first term down, ux plus h times v x plus h. And now I'm going to subtract this and add it. So here we'll have minus u x plus h v of x, and then plus u x plus h vx minus ux vx. And all of this is divided by h. So now we're going to rewrite it slightly differently. The derivative of the product uv with respect to x is equal to the limit as h goes to 0. And here we'll put brackets out here. And the first one here is u x plus h times v x plus h. And we're going to put another bracket here. And this term is this one. And then what I'm going to do here is I'm going to put the second term next, which has the u of x plus h out front, but then a minus vx. So that takes care of the first two. Then for the next one, so I noticed that I'm going to put the last two down now. Let's do with the v of x factored out. So this would be u of x plus h, this one, minus u of x would get me the second one. Put my brackets out here and divide by h. Now, can we say that the limit of this whole thing is equal to the limit of each part in the sum? And here is where in your calculus course, they will list these limit rules, and often in the appendix, they'll prove them. Now, we're not going to prove them because these are reasonable rules, but remember, this does not replace your calculus course. You're supposed to take the calculus course. When I was chair of physics for many years, I wanted my physics majors, I wanted them always to take calculus with a mathematician. So I'm going to list the limit rules, kind of like they do in a calculus book, but I won't have an appendix. I'll refer you to the calculus book for the proofs. Now, this is the book I use, Thomas, which is now called Thomas's Calculus. I used that decades ago, and they're in their 14th edition, and now other authors have taken over since it's been so many years. And here we have Haas, Heil, and Weir, keeping the tradition of Thomas, which goes back so many years. So these are called the limit rules, and first one is a sum rule, that if we have the limit as x goes to a of f of x plus g of x, suppose the limit of f of x by itself would give you L, and say the limit of the second one by itself would give you M. Then the sum rule says, well, the limit of the combination, the sum, is simply just add the limits. See, these all appear reasonable. And then you have the difference. The difference rule would simply be with a minus sign. That would work. And there's another rule where you have a constant multiple, where if you have c times f of x and you want to have a limit there, you'll have simply c times L. Yeah, see, the g goes with the m and the f goes with the L, so no problem. Constant doesn't mess anything up. And then here we have the product rule, that if you have, say, f of x times g of x and you want to take some limit there, all you have to do is take the limits individually and multiply them together. Then there's the quotient rule, if you have f of x over g of x and you're taking some limit, you would simply take the limits of the individual components and divide. And there's also a power rule where if you have f of x taken to the nth power and take some limit, that'd be simply taking the function to that limit and say get L and then go to the nth power. And then finally there's the root rule that if you take the nth root of the function, all you have to do is take the nth root of the limit to get the limit of this combination of things. So we're going to use these rules here. We're going to be using the addition rule, and we'll be using, look, we have a multiplication here, two things that are multiplying. So we're going to use these rules and everything's going to work out so neatly. So here we have the derivative of the product, and that's going to equal here the limit. I'm going to write each of these pieces separately. So as h goes to 0, I'm going to have u of x plus h times v of x plus h minus v of x over h. So that's taking this one here, the u of x plus h out front, and then just copy the case with the v being x plus h evaluated there, and then minus v of x. So then we're going to add to this the limit as h goes to 0, and now we're going to copy this one down. So this, and now we're going to copy this one down. So we have the v of x on the outside, that we have u x plus h minus u of x, and that's over h. And now I'm not going to write out the product rule where you would, the product rule for limits where you would take the limit of this one and times the limit of the second one. I'm just gonna write it down here in one step, that this would get you u of x, and this would be the derivative of v of x with respect to x. And then over here, you would have, for the first one, v of x, and then the second part would be the derivative of u with respect to x. You have the u of x plus h minus the u of x over h. So this would be the result, and here I'll just write this down in an abbreviated form where I'll simply write, I'm going to remember this as the derivative of the first times the second, and put the second first. And this is up to you how you would like to memorize this, but I somehow remember it by saying take the derivative of the first times the second plus the first times the derivative of the second. But it's a simple rule to memorize because you're basically taking the derivative of one of them, multiplying by the other function, and then flipping and getting the other one down. So you have u and v, so du dx times v, and then u times dv dx. Now what I would like to do here is check this formula, which a case that I can do very easily, where let u equal x squared and let v equal 2x cubed, then uv would be 2 times x to the 5th power. So I know my answer very, very quickly here, that the derivative of the product I know is you bring the 5 down, get 10x, and you subtract 1 on the exponent. I know that's the answer. But can we get that answer using this combination here? Well, the v would be 2x cubed And the u is x squared, so the derivative would be 2x. So this would be multiplied by 2x. And then over here, the u is x squared. And then the v is 2x cubed, so you bring the 3 down, you get 6x squared. So this would be times 6x squared. And then if you look at this combination here, this is 2 times 2 is a 4. And that's a 4x to the 4th power. And over here, we have 6x to the 4th power. So if we add 4 plus 6, we get 10. And the power is correct, x to the 4th. So there you have the product rule.